to the practical machine learning for computer vision. Today we shall be looking at probability, odds, logits, sigmoid, and softmax. If you have ever done any machine learning experiment, you should have heard of the word sigmoid, or by extension softmax. But we'll quickly break it down as to how we arrive to this sigmoid or softmax, and we want to have a underlining understanding of this concept. So the output of our classification is a probability, and that's what we're interested in. Essentially, we want to know how confident is our network or our model or our classifier. All these are synonymous to whatever prediction is making. So our our classification model is just giving us a probability of how confident it is for a given task. So probability, as you know from high school math, is ranges between 0 and 1. So if our model says the probability is 0, then that means our model is saying that it's not possible for that particular uh, event to occur. And if the probability is close to 1, then you know that means there's a high chance, high likelihood that that event will occur. So building a model that classifies a machine part as defective or not defective, it will just output the probability that the part is defective. And of course, if you know that the task ahead is a classification, binary classification task, that is either 0 or 1, they are just two classes. Then once we know the probability of 1, we can simply get the probability of the other class by just subtracting uh, uh, that probability from 1. So if the probability that an event will happen is p, then the probability that that event will not happen will just be 1 minus p. Now there's a concept of what you call the odds, and the odds is defined mathematically by this equation, which is p over 1 minus p. In what that says is that the odds that it will happen in any given trial is the probability of the event occurring divided by the probability of it not occurring. So that's so if p is equal to 0.25, then you can expect that the odd will be equals to 0.25 divided by 0.75, and that is just a ratio 1 to 3. All right. So, and now comes the concept of logit. Logit is a natural logarithm. So when you take the log of the odd, then you get what you refer to as the logit. So if p is 0.25, then if you take the log, the natural logarithm of the odd. So first of all, you calculate the odd as we have done here, which is this. So this is the inside here is the odd. Then you take the log, the natural log of the odd, then you can get the logit. So and so for instance, for an event with p equals to 0.75, the logit is 1.098. Now the probability, as the probability approaches to 0, the logit approaches negative infinity, and as the probability approaches 1, the logit approaches positive infinity. As you can see here, the probability of um, uh, the logit here is p is equal to 0. Logit is 1.098. So as the probability is 0.75, then you see that the logit is 1.098. That's just the characteristics of the logit. So now what we now do in sigmoid is this. The sigmoid is calculated mathematically with this. So if your input is y, so represent the sigmoid function with this row. So the sigmoid is mathematically represented as 1 over 1 plus e raised to power negative y, which e is exponential. So we can just take the inverse of the logit. So the sigmoid is the inverse of the logit function. So if you put in, if your logit is 1.098, then if you put 1.098 here, then you're going to get the sigmoid is 0.75. Okay, now so sigmoid is in the range of 0 and 1. So if you have a dense layer in Keras with just one output node, by applying the sigmoid, we can obtain a binary classifier that outputs a valid probability. And this is shown here. On the y-axis, we have the probability, which goes from 0 to 1. So this is the sigmoid. Now, as we have negative values input to our sigmoid, if our logit is negative, the probability will be getting close to 0. The sigmoid with squashes is close to 0. If the probability is getting towards positive, it will squashes it to if our logit is getting towards positive, is positive, it will be squashing it towards probability of 1. And if it is in the middle, then the probability will be around the 0.5. Okay, so for instance, so here, if we trace this is 0, you will see that it will give us 0.5. Okay, now so the softmax is just like the sigmoid, but it just works on more than 2 classes. So as I call it, is multi-class counterpart of the sigmoid. So if we have n mutually exclusive event, so there are logits given this. So this is a mathematical representation of the softmax. Okay, now the characteristics of the Fox softmax function is that it's non-linear and it has the effect of squashing low values and boosting the maximum, as you can see here. So you can see if the probability is let's say the logit given us here is this blue. If the logit is that blue, we can see that the softmax is this orange, this red. You see that it's lower, and you will see here that if the logit that we have here is this I, we can see that the softmax makes it higher. The similar thing is observed here. So that's why we say that it has the effect of squashing low values and boosting the maximum one. So that's essentially about the logit, sigmoid, softmax, and the odds. Thank you very much and see you in the next one.